Hello, everyone. Thanks for joining in today. My name is Angela, and I am the marketing manager here with Streetwave. Before we begin, I just wanted to inform you that this webinar will be recorded, and if you have any questions throughout the presentation, please feel free to type them in the question box, and we will get them answered to you guys right after. Today's presentation, we have Paul and Peter that they will be presenting about SAF and licensed microwaves. So I have Paul and I believe to start off.
Actually, it'll be Peter. Go ahead, Peter.
Are you going to do this intro of this first slide, or are you going to move to the next one? Okay.
Okay. Yeah. So my name is Paul Kessner. I'm the territory manager for SAF, managing the Western United States, and Peter will also be presenting. Peter DiCarlo. He is our vice president of sales and marketing. What we're going to speak about today is SAF licensed microwave products. We'll tell you who we are, why we use licensed microwave versus unlicensed microwave frequencies, and then provide you an overview of our of the SAF product portfolio. So take it away, Pete.
Thank you, Paul. Hello, everyone. My name is Peter, and I'm the Vice President of Marketing and Sales for SAF North America. And I'm going to start out by telling you a little bit about SAF. SAF is a global company. Our North American headquarters is outside of Denver, Colorado, in Aurora. And SAF has been building microwave radios for 20 years, incorporated in 1999. And one thing you should know about SAF is that we're a publicly traded company. So if there are questions about our longevity, whether our support is going to be around next year, or future product offerings will be coming from us next year and future years, it's easy to look at our financial statements and validate our future existence. We like to talk about ourselves as a full cycle manufacturer, and what that means is, if you look at the pictures to the right, is that we do everything from the research and development related to our products, the production of our products, and the testing, the quality control of our products. And we're certainly not a chip manufacturer, and certainly we do have vendors that supply parts to us, but we build everything from the board up. And we're very serious about the quality of our products, and you can see we're ISO 9001 certified. And in North America, we're not just a sales and marketing team. At our North American headquarters here in Colorado, we have not only sales support, marketing support, but we have logistics support, which means we have a warehouse here, and we warehouse product here, and we ship product to North America from Colorado. And also, maybe even more important, is that we do have a technical support team here also to support our products. So we have worldwide support. Next slide, please. We talk about the SAF Performance Guarantee, and this has to do with this idea of quality control, building quality products. And we stress test every product that's shipped out the door. So, and when I say that, I don't mean that for a particular product we pull one off the production line and test it once in a while. We test every single radio that goes out the door at environment to make sure when you're looking at the data sheet that it reflects what's on the data sheet. And that's what we call the SAF Performance Guarantee. Next. SAF differentiators are those things I just talked about, our sincere commitment to quality. And no upgrade keys, that's an interesting one. When we sell you a product, there are no capacity upgrades, feature function upgrades. What you buy is what you get. It runs full out. On products like the Integra Alumina, to reflect our quality consciousness, we offer a 5-year warranty on those products. Short lead times, that's this whole idea about having a warehouse and logistics here in North America, obtaining forecasts, of course, from customers like yourselves, and being being able to inventory product here in Colorado and provide short times, delivery times. And of course, excellent tech support, which I referenced, and we have a tech support team here to support all the products. Next.
This is we'll talk now about licensed microwave versus unlicensed or license exempt wireless frequencies. The graph along the bottom represents the spectrum as it's allocated by the FCC here in the United States, starting at the low end where you would have VHF and UHF frequencies for television, two-way radio types of communications, SCADA, industrial types of communications, wireless communications device. Starting at approximately 6 gigahertz, or well, really actually at about 2.4 gigahertz, you get into broadband wireless frequencies that are utilized for point-to-point and point-to-multipoint data and voice types of communications by service providers, government agencies, and also enterprise or industry. At 6 gigahertz is where what we refer to as common carrier license frequencies in the United States start, and they run all the way up to 38 gigahertz. The most commonly allocated frequencies and used frequencies by telecommunications and internet service providers, government agencies are 6, 11, 18, and 23 gigahertz. You can typically the lower the frequency, the further the RF wave will propagate, and hence the longer the distance you can transmit data or voice. So for example, the 6 gigahertz frequency it's very feasible to use it at distances up to 50 miles and beyond. The 11 and the 18 gigahertz frequencies are optimized and supported by available channels from the FCC up to 80 megahertz, enabling us within the SAF product line to deliver speeds of up to 1.2 gigabits capacity. So as opposed to a license exempt frequency that you're able to just purchase equipment and deploy it without any registration or licensing or coordination activities and services by a frequency coordinator in the FCC. You can just install and turn up those networks and operate them freely. The frequencies I referenced before, the 6 to 38 gigahertz, require an application process and registration and coordination by the FCC. And so what they'll do is they'll license each transmitter with a specific frequency pair, one for transmitting and one for receiving, that then they assign to the licensee. Excuse me. And by having that frequency assigned at those communication sites or by GPS coordinates, you have protection, and you exclusively get to use that frequency pair. No one else can, mitigating the possibility of interference. Moving up the graph, the horizontal axis on the bottom, there are what we call millimeter wave band frequencies. You may be familiar with radios that operate in these frequencies, primarily 60 and 80 gigahertz. SAF does have, we do have products currently in development in those frequencies, but we're not offering them on the market at this point in time. What's characteristics of those frequencies is that as a high frequency. They don't propagate for very far due to the rate of oxygen absorption at those higher frequencies. Hence, their typical usages are for high capacity, very short distance types of point-to-point or point-to-multipoint like wireless applications, typically less than 1.5 miles. So that some of the aspects of unlicensed wireless versus licensed wireless are that unlicensed radios are generally less expensive. Their performance can be unpredictable due to the possibility of noise and interference, mainly in the 5 gigahertz and 2.4 gigahertz, and even in the 3.65 bands or 24 gigahertz bands. There's been a proliferation of devices using those unlicensed bands over the years, ranging from SOHO products like Wi-Fi access points, cordless phones, that kind of a thing, to point-to-multipoint systems that are often used by telecommunications service providers in 5 gigahertz or 3.65 frequencies that use a base station with a sectoral antenna, wide beam antenna that basically sprays RF in a wide area that can create interference in many cases in densely populated metropolitan areas or urban areas. And by virtue of this noise and the unpredictability of it, it's impossible to design a network and plan a guaranteed SLA or service level agreement, 5 nines availability or uptime, if you will. One of the other aspects of the license exempt systems is, especially in 5 gigahertz and 2.4 gigahertz, they're TDD or time division duplex systems that basically intermittently transmit and receive. Hence, there's a delay between the transmission and the reception between the devices, causing higher latency, which can lead to jitter, lower quality of service for voice traffic, and other quality of service degradations over the point-to-point or point-to-multipoint systems. And whereas licensed links are generally more expensive, however, as the industry grows, the volume of radios sold and developed, they are becoming less expensive. The main reason for using them is that by being granted a licensed frequency pair from the FCC enables you to operate virtually without interference. There are some rare exceptions to that, but for the most part, you can predict the performance. You can engineer or architect a network or a link, if you will, to 5 nines availability, which is the equivalent of fiber or wireline-based services availabilities, and you can guarantee your customer in SLA if you're operating a telecommunications network and providing a finished service to your customer. So by not having to worry about interference, you'd result in fewer truck rolls, less trips to the site to diagnose the source of interference, and then adjust the channels in the radios to operate interference free, if that's even possible with the amount of noise out there. It allows you to deliver a higher quality of service over your network, and be able to support business continuity as well as disaster recovery, life safety types of applications, and traffic for public safety networks can be supported. As a result of the higher reliability, your customer retention will be better if you're a service provider, and basically due to the high level of QoS and a high SLA, a guaranteed SLA, you can generally charge more for that finished service and be more profitable as a network operator. To the right, you see just a small chart there talking about wireline services and the fact that they're generally 5.9 availability types of SLAs, can support those high SLAs, and licensed is equivalent with that, using full duplex or bidirectional transmissions. Unlicensed systems being TDD or half duplex, as we discussed before, and as a result of that, experience are susceptible to latency. We'll start here by just providing a snapshot and an overview of SAF products. The Integra series, which are on the vertical axis, starting on the vertical axis, and then on you'll see on the far right column the capacities that are supported by each product series, and along the bottom the frequency ranges that are supported by each product series. So starting with the Integras are our latest product series. They've been out for about 2 years now, and we continue to improve and enhance the product, and we have a roadmap with further improvements in terms of performance and feature sets well into the future planned for the Integra series radios, which are a full outdoor unit architecture. So that means that they connect directly to an antenna on a tower or a mast on a rooftop, and you run either a fiber or Cat5, Cat6 from your network device up to directly to the radio. We'll get into the finer, the more specific products, the S and the W, and those variants and what they denote and the differences between them later. CFIP Lumina is also a full outdoor unit product. It's our flagship product. Pretty much put us on the map approximately 5 years ago here in the U.S. We still sell a great deal of those, even though they don't have the similar as advanced feature sets or as quite as high a performance as the Integra series. They're still a very popular radio and sell very well for us. The CFIP Phoenix variations that you see there, the Phoenix, the C, and the M, are split mount architecture radios, which are generally used by industrial clients or telecommunications clients that have a requirement for TDD or I should say SONET types of base services that are migrating from those TDD based services to IP services, and we'll get into the differences between those variants as well. CFIP 106 and 108 is a full outdoor unit licensed microwave system. These are all these series of products are supported in licensed frequencies, generally from 6 to 38 gigahertz. The CFIP 106 is a lower capacity yet very reliable full outdoor licensed radio system that's great for requirements, license requirements of 100 megabits capacity or less. I'll note right now that when SAF specifies capacities, those are full duplex capacities, so that would be bidirectional. So when we say 883 or 366, we mean that's the capacity you'll get in each direction over a link. Free Mile is our license exempt series of products available in 5 gigahertz and then 17 gigahertz, which is a unlicensed frequency available outside of the U.S., but within the U.S., it supports the 24 gigahertz license-exempt frequency. It's a 100 meg capacity, a very high quality, high MTBF radio. And then CFIP Marathon, you won't see here, we rarely see sold here in the United States, just by virtue of the fact that it's a very low frequency, sub 2 gigahertz frequency radio system designed for industrial usages requiring very long distance links and low throughput. As you see there, it supports up to 43 megabits, but in the the sub 2 gig frequencies, the waves will propagate hundreds of miles, so it can support 150 mile distances very easily. We'll move into the Integra series of radios. As I mentioned, this is our latest family or series of products, most advanced in terms of performance and feature sets. They are full outdoor unit radios that are available in a number of variations. You'll see there are the Integra and the Integra G, Integra and Integra G, Integra S, GS, and Integra W / there should be a WS there as well. So the S or the G denotes, I should say the G denotes the modem, which in the case of Integra will support up to 2048 QAM. The Integra and the Integra G are available in an integrated antenna, a single unit depicted in the picture on the bottom left corner, that the integrated antennas will come in either a 1 or a 2 foot version, and they're supported in 15 to 42 gigahertz frequencies. Integra S denotes slip fit, or GS would denote slip fit with the G series modem. And that's also a full outdoor unit that can be connected to an external antennas up to 10 feet or beyond. Are available in 6 to 42 gigahertz frequencies. And you'll see below the bottom picture in the middle represents the Integra S there in higher frequencies ranging from 15 gigahertz to all the way up to 42 gigahertz. Then the Integra SWS in 6 to 13 gigahertz form factor is depicted in the picture on the bottom right. Integra W denotes wideband, so that'll support an 80 megahertz wide channel in 18 gigahertz and 11 gigahertz. Again, it's a full outdoor unit radio, 1 or 2 foot integrated antennas, or the WS version, the slip fit version, will support up to 10 foot antennas as well in 6 to 42 gigahertz frequencies. Feature sets, S versus W and WS. So the S, the distinguishing features between the S and the WS versions are one, that the S and the GS have a very advanced, or I should say a smart switch with a carrier Ethernet 6-core processor in it, whereas the W has a unmanaged gigabit Ethernet switch that doesn't support the wealth of Ethernet functionality that the S and the GS supports, and that includes is listed there, 802.1q VLANs, a variety of quality of service, SYNC for LTE networks, header compression, and more. Whereas the W and the WS being a being an unmanaged switch, basically is a transparent bridge. So any kind of Ethernet functionality, QoS, VLANs, that kind of thing would have to be configured upstream from it in an external box, a third-party router or a switch. The S and the GS support one RJ45 port and PoE, and then two SFPs, so either for management or data. The WS supports two RJ45 ports, both supporting PoE, and then one additional SFP port, presumably for fiber, if you want to run fiber to the radio from your network device. The S and the GS modems will support up to 490 megabits with a 60 megahertz FCC channel at 2048 QAM, and the modems in the W and the WS will actually support up to 883 megabits with 112 megahertz channel, though you would rarely ever encounter an opportunity to get a channel that large in the U.S. I'd say 99.9% of the time, the widest channel available from the FCC in 11 and 18 gigahertz is 80 megahertz. So in that case, it supports 643 megabits of full duplex at 1024 QAM. The transmit power, the S and the GS have a little bit lower transmit power. For example, 19 dBm in 11 gigahertz at 1024 QAM, whereas the WS was designed with very high transmit power to support the wider channel size and the high modulation to be able to get high availability, good link quality, with high capacity at longer distances using smaller antennas. So 24 dBm at 1024 QAM in 11 gigahertz is the transmit output power of the W and the WS series radios. Then from a management standpoint, S and GS support in-band, and the W and the WS support out-of-band, and hence they would require running a separate cable for your management traffic, separating it from your network traffic. These both radios support 1+0 and 2+0 configurations. With the carrier Ethernet network processor, the S and the GS radios will actually perform link aggregation internally or link bonding internally, whereas the W and the WS support 2+0 as well, but they would have the aggregation of the data streams would have to be done externally in a third-party switch or router. The design of the Integra is very innovative. So the integrated version, as I mentioned before, is available with 1 or 2 foot antennas. With the S versions, you can use external antennas. They all have a transparent service port that offers a multi-function LED lighting, so you can actually see power, sync, RSL functions are working from the ground by virtue of the blinking lights in the radio ports on the bottom of the radio. There's a 3.5 millimeter headphone jack, either for use of a voltmeter for alignment, or a headset can be plugged in there. There's an audio tonal alignment feature, and then there's also a USB port for terminal access or local access for configuration and monitoring with a laptop. There's 3 gigabit interfaces. One electrical is the SAF nomenclature for a copper or an RJ45 port that offers PoE with 2 SFPs, and then on the WS there's 2 electrical ports and 1 SFP for fiber interfaces. You can see it has this loop mount, center mount design, which makes the integrated version very, very easy to install. They're very lightweight and easy to install. So the antennas on the integrated versions are designed with aluminum alloy, or manufactured with aluminum alloy as opposed to steel, making them extremely lightweight. The full outdoor unit cover is milled from aluminum sheet instead of die casting aluminum, which makes it more anti-corrosive. The cover of the radio is a very innovative plastic metallic mesh composite, so it's fully compliant with EMC, FCC EMC standards, and 100% corrosion free. And the mounting hardware is all stainless steel as well, corrosion free. So features of the we'll dive in a little bit deeper of the features of the S and the G and the GS versions. So in the G and the GS versions will support up to 490 megabits full duplex capacity with a 60 meg channel in 1+0, or 900 up to 950 megabits, again with the 60 meg channel full duplex in a 2+0 configuration, and up to 1 gigabit utilizing header compression in 1+0. So the frequency bands supported are 6 to 42 gigahertz, and channel sizes starting at 5 megahertz going up to 60 megahertz on the high end. Modulations from 4 to 1024 QAM on the Integra and the Integra S. And the G and the GS the modem supports up to 2048 QAM. Just to I would note that the S and the Integra S, are right now they're being twilighted and will ultimately be end of life, and will only be offering the GS modem with the higher QAM and the higher capacity. So we talked about the transmit power being 31 dBm at 4 QAM, or 23 dBm at 1024 with automatic transmit power control, and modulations from 4 to 28 QAM. Back up a little bit there with hitless ACM for rain fade mitigation. Power supplies starting at 36 to 57 volt DC, or 22 to 60 volts, supporting PoE with a SAF PoE injector. And again, a key difference between S and G versus W and WS are that it has the built-in 6-core network processor supporting the wealth of Ethernet carrier Ethernet functionality. All of that's listed below, including the QoS, SNMP, Radius, and then a variety of synchronization protocols for LTE networks, and 256-bit AES encryption if you have customers that require a high level of security, like financial institutions or government agencies, public safety agencies, federal agencies, so forth and so on. Integra W and WS are, again, the distinguishing feature about that versus the G and the S are that it supports 643 megabits with the wider channel, the 80 megahertz channel, in 11 and 18 gigahertz, and up to 1.2 gigabits in a 2+0 configuration. They support the bands from 6 to 42 gigahertz. And channel sizes, again, starting at 5 megahertz all the way up to 80 meg. Modulations up to 1024 QAM at this point in time. There's 2048 QAM on the roadmap, also with hitless ACM. Transmit power of 33 dBm at the low QAM, 4 QAM, or 28 dBm at at 1024 QAM. Again, when you're talking about wideband radio supporting 80 megahertz channels and high modulations, 1024 QAM and up, transmit power is king. These are some of the highest transmit output power and radios available on the market. And what that translates to is better link quality, better SLA, given all things equal over a path and using smaller antennas. Similar power supplies, 36, 57 volt DC or 22 to 60 volt DC with the SAF PoE. PoE is supported, as I mentioned, and this radio does require that for management traffic, you run it out of band, which makes it highly secure. And then it has user configurable traffic ports, so you can rate limit the connection to your customer switch if you're providing them a dedicated circuit for a finished service. And then again, it has 2 electrical RJ45 ports and 1 SFP versus the opposite in the S and GS radios that have 2 SFPs and 1 RJ45. So our SAF antennas, talk about them for a quick second here. We OEM Andrew or CommScope antennas, Archivator Liax, Tongyu, Granta, and RFS should be on that list as well. So in the United States, we generally sell the Andrew CommScope antennas and the RFS antennas because they're lower cost based on the fact that they ship from the United States. I believe the East Coast in the case of RFS, and then from Texas in the case of Andrew. So we have access to their entire product lines. We resell them at very, 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 very competitive and reasonable prices through our channel of resellers like Streakwave, and we have access to their value line antennas and their high performance antennas, ranging anywhere from 1 foot to 10 foot and beyond. From bands to supporting bands from 6 to 42 gigahertz. Single pole or dual pole versions for 2+0 or XPIC types of applications, and they're all slip fitted, so they fit directly to the SAF radios without, in most cases, an adapter. We do, however, we'll note, offer a variety of adapters to adapt SAF radios to antennas that maybe were previously used with other manufacturer radios having different interfaces. So in many cases, if you're upgrading a different manufacturer's link with a SAF link, you can repurpose the antennas just simply by using the adapters that we provide, not having to buy new antennas. Another distinguishing feature of Integra series radios is the web GUI, the management system for monitoring performance and configuring the radios is very intuitive and very simple to use. Our radios are widely regarded as some of the easiest radios to install and configure and manage, reducing installation time and cost of installations, time at the site, truck rolls, etc. And this is just a quick shot of the main status page there, showing some of the key performance parameters and configuration parameters. They're all listed there very clearly. Over on the right-hand side, you see the system summary, which tells you the receive level and the transmit and receive polarizations of the link. Very easy to follow and monitor. So that's it for Integra series radios. I'll move into the CFIP Lumina radios. Again, they're our flagship radios. They were one of our first full outdoor unit products, supporting relatively high capacity up to 366 megabits with 56 megahertz channels, wide channels, in that's full duplex in a 1+0 configuration, or up to 740 megabits in 2+0 configurations with a 56 meg channel. Same as the Integra, it supports frequencies from 6 to 42 gigahertz, channel sizes, T differentiators from 5 up to 56 megahertz as opposed to 60 in the case of Integra G and GS, and then 80 in the case of Integra W, WS. Also, modulations from 4 to 256 QAM with hitless ACM, and pretty reasonable transmit power, 19 dBm at 4 QAM or 23 at 256 with ATPC. Receive sensitivity level there is 64 dBm with the 56 meg channel at 1024 QAM, or 87 at pretty high at 4 QAM. Power supplies again support just like the Integra's 36 to 57 volt DC or 22 to 60 volt DC with our proprietary PoE, and the CFIP has a pretty smart switch in it. CFIP Lumina series radios do. So it has a pretty good wide variety of supports Ethernet layer 2 functionality, including 2+0 internal link aggregation via layer 2, variety of QoS functionality and VLANs, packet buffer, and like the Integra, I don't know that I mentioned it, they have a 5-year manufacturer factory warranty that is the longest warranty in the industry. And again, no charge for upgrade keys. The radios come completely unlocked. All internal functionality of the radios is available to you at the price that you pay when you purchase it. This is a quick snapshot of the data sheet there. So it talks about the frequency ranges on the left-hand side there, different modulations, capacity from 34 to 366 meg, and that it supports configurations of 1+0, 2+0, or 1+1 hot standby for customers requiring high availability for business continuity, or public safety networks supporting life safety traffic. Traffic interfaces are pretty flexible. You can order the radio with either just RJ45 ports, just fiber ports, multi-motor fiber, or we offer a hybrid version that has a GigE RJ45 port and a GigE multi-mode or single-mode fiber port, providing flexibility there in terms of interfaces. It supports SNMP and loopbacks, a variety of Ethernet functionality, as I mentioned. Frame sizes up to 9,728 bytes. Packet buffer of 128 kilobits. Some advanced Ethernet QoS, including spanning tree protocol. And it's a pretty small form factor as well. There's some pictures of the optical, the electrical, again the RJ45 ports, and then the hybrid, which has both. You'll notice that there's an RSSI port on all radios to hook up a voltmeter for alignment. The BNC port will allow you to locally access the management and the GUI of the radio for configuration and troubleshooting. And a DC port if you want to run DC power. So here's wiring diagrams of the Lumina. The first figure, 1.15 there, picture illustrates utilizing PoE. So one thing about the CFIP Lumina that's different than the Integras is that It does not have an internal PoE splitter, so running PoE entails installing a PoE Ethernet splitter in surge arrestor, typically right next to the radios, as is shown in the picture there. So you would run your DC power, Cat5 up to the splitter, in which case the splitter splits the power and the data, feeding the DC port and the in this case the RJ45 port. 1.13 shows an optical interface using a DC power source, running power separately from the fiber, and then running fiber directly to the radio via an ODC connector at the radio. So at this point, I'll toss it over to Peter, and he'll tell you about our Phoenix series radios. Peter, are you ready? Hello?
Ready? Sorry, Paul, had the mic off.
No worries.
Thank you, Paul. Before I talk about the Phoenix, I'm just going to step back and address one item. Both Paul and I mentioned that we have no feature keys. And as Paul was talking about AES encryption, I was reminded there is one exception. Many of our customers don't really require AES encryption, so we actually do have a key to turn on AES encryption, and we do charge for that. But as you know, every product that uses AES encryption has to pay that fee. So basically, we're just passing on that fee. So that is the only exception. CFIP Phoenix. This is a family of products that's full indoor and split, and as Paul mentioned earlier, they are a family. There's the Phoenix X, the Phoenix M, and the Phoenix C. What's unique about these products is that these are the products that have the feature and a function set and feature modules that allow us to pull together legacy networks and bring them into the IP world. You know, so telecoms, it's that kind of telecom architecture. You can see massive T1 interfaces here, 20 T1s plus. These products are available 6 to 38 gigahertz. They run at 256 QAM, and they can deliver 363 megabits per second capacity. And these products, like the other products, they can be configured in not just 1+0, 2+0, so you can multiply that capacity. And in fact, many of our products, they can be configured 3+0, 4+0, and even we're configuring them up to 8+0 configurations using what we call branching units, internal and external branching units, big, massive couplers. So these are the kind of products that allow us to migrate from TDM to IP networks. The Phoenix X, you can see it has an advanced gigabit Ethernet interface, but it has 20 T1s. Okay, so that's a migration from T1, a massive T1 complex, to IP. Like other products, hitless ACM and ATPC, and this product has a fanless design. Phoenix M, it's a modular design. All these products are modular. They have various modules that allow you to stack T1s. The Phoenix C, you can see it has a asynchronous serial interface. That's kind of a separate module that you buy with the Phoenix C if that's the direction you choose to go. So these are complex in the sense that they have many modules, many possible interfaces, and I would recommend when dealing with these products that you kind of reach out to our team and let us work with you a little bit to help design a final solution, because they can get fairly complex. Potential verticals for these products are, you know, they can be telecoms, but there are also industrial verticals that use these. and public safety. You know, these products integrate in the legacy public safety architectures very well. Next slide, please. Paul?
Yeah, it's stuck. There we go.
Okay. No? Oh, is that right? Okay. Yeah, okay, that's good. That's good. Recognize it. As I said, this can be either a fully indoor solution or a split solution, and you can see the Phoenix ODU there representing the split solution, directly mount to SAF adapted antennas, with a remote mount using a flexible waveguide. Diplexers can be built in or can be external. And then you see the Phoenix IRFU, the indoor radio frequency unit, and that's the counterpart to the Phoenix modems that's rack mounted and is part of the full indoor solution. And again, diplexers built in or out. If you're looking at this kind of solution, again, I recommend you reach out to our teams because there are many things to think about, especially as you try to integrate into existing infrastructures with external waveguides, etc. There's a lot to define to deploy a system like this. Next, Paul. Okay, main features, Phoenix C, hitless adaptive coding and modulation. You see that on all our products in ATPC. Unique about this product would be really the things we already talked about. These are all really standard features that I think you find on all our products, not really unique to Phoenix C. VLANs, Ethernet traffic, QoS support, those are features you find on Tegras, Luminous, etc. Synchronous Ethernet, and we talked about AES encryption. So these are all standard features, I would say, not specifically unique to Phoenix C. Next, Paul. Spectrum Compact and the SC and the SD, the signal generator. I'll talk about those in a minute, but basically we're a point-to-point radio company. You didn't hear us talk about point-to-multipoint. It's point-to-point, mostly licensed point-to-point. And there's one exception, and that's the Spectrum Compact. And the Spectrum Compact really comes out of us working on very large projects and deploying networks ourselves. We had a really large project at one time. It was not in the United States, it was in Northern Africa, and we were responsible for deployment into that product. So we designed a tool to deploy that product expeditiously and reliably. So it became known as the Spectrum Compact. So it's a tool designed by engineers for use by engineers. As it says here, it's really light. It's available in frequencies from 2 to 40. What makes it so small, this is a handheld device. And what makes it unique is it is handheld as compared to the spectrum analyzers that you can buy out there. They're really meant to be laboratory analyzers, and if you want to take them in the field, you have to carry them in a backpack. This thing literally you can hold in your hand, carry to the field, climb up a tower with it in your pocket or on your belt, and it's very comfortable to use, and it's easy to use. So we talk about it's kind of the must-have tool to deploy expeditiously and reliably. Next. So what makes it unique? We talked about that it's the smallest spectrum analyzer available. Now, what makes it so small is that it is broken out into 5 different models. So in one model, we haven't squeezed in 2 to 40 gigahertz. There's actually 5 models that take you from 2 to 40 gigahertz. The capacitive LCD screen, so it's easy to use with gloves. It's a very intuitive interface. We offer free training for it if needed. And it's vendor neutral. So it's not just for SAF products. You can use it to deploy anyone's products. It's the lowest price in the industry. And normally we don't throw out prices at all, but the reason that price stands out, $5,000, is that if you go buy a standard spectrum analyzer, it's 10 times that price. Right, so good price point. Next one, Paul. Okay, so there you see the 5 models. It's broken out into those ranges 2 to 8, 6 to 12, 10 to 18, 17 to 24, and 24 to 40. Many of our customers, you know, they're not buying just one at a time because they're working with several different frequencies, and they're buying kits normally of 2 or 3 of these spectrum analyzers. Next one. There's more detail on this model, and I guess the only part of this detail that I will focus you on, this is all available in our data sheets online, is this minus 105 dBm. It's extremely sensitive. It's so sensitive, in fact, that if you buy the kit, the basic kit has a spectrum analyzer in it, a little coax cable that goes to a waveguide, and if you use that simple waveguide without even an antenna, you can do good work even from the ground using a spectrum compact, looking for interference or whether you're on center frequency, etc. Next, and this is what's in the standard kit. So it's a spectrum compact. It's that little coax cable I told you about. It's a USB cable and charger, a couple of attenuators, a waveguide, and that would be a standard kit. Go ahead, next, Paul. The signal generator is the counterpart. You can go a long way with the spectrum compact with analyzing problems you have in the field, but if you want to do, for example, a site survey and you have no antennas or radios up in the air, you just want to know if you've got good line of sight. Well, you've got a signal generator that you can pair with the spectrum compact and do line of sight investigations. If you have and you're ready to mount antennas and not radios, you're in that situation, you can use it for that. Signal generator one side, spectrum compact on the other, and do antenna alignments, etc. Go ahead, Paul. And the spectrum generator, like the spectrum compact, is broken out into several models. Here you see 4 models, 6 to 12, 10 to 18, 17 to 24, and 24 to 40. Next, Paul. All right, there's much of the same information. Adjustable frequency steps, adjustable power step, 1 dBm. The signal form is a continuous waveform. Interfaces, mini USB. I guess that's a good one to talk about, both for, especially for the spectrum compact, and I missed that there, is that the spectrum compact comes with software and an application, and it comes with a USB cable, not just for charging, so that you can store in the spectrum compact what you've captured, and you can download that and do more analysis on it with the software that comes with it. And maybe even more important, what you can do with that information and with the software is generate reports. So you've got a team out there, and you want to verify after they've deployed the link that it is on frequency, that it has met link budget. You can use the Spectrum Compact to capture that information, download it to an application, and generate that report. Next. And these are kind of applications, you know, link site planning. So you go out there with a Spectrum Compact and a signal generator, do some initial line of sight planning. You could do microwave link installation, starting with antenna alignment. I don't know how many times I've worked with customers that spend days and sometimes, unfortunately, even weeks trying to align their antennas. And with the Spectrum Compact, you can literally you can scan the lobes without worrying about whether you're going to find this center lobe, because it's tracing and recording those. And it has a mode where you can actually lock in the center, the main lobe, and go right back to it. So site acceptance, that's the idea about generating reports. What did I deploy, and did I meet link budget? Link maintenance, of course, and that's something you do from the ground, not necessarily climbing a tower. You can go out to a site, point the Spectrum Compact or the waveguide or an antenna if you've got it mounted on an antenna, up to your radio, to your antenna, and determine whether it's on frequency. You can see interference if it's being interfered with. Some of those things eventually may require climbing the tower if you see interference, to make sure that you're looking at the interference that's directed at your radio. And just link troubleshooting in general. Next. More on applications. We talked about site surveys, radio link installation, site acceptance, troubleshooting, and maintenance. Applications, free radio channel selection. So one of the things you can do is to go scan and see if a channel is available where you plan on deploying your radio and your antenna. If you can look for interference and your radio after it's deployed. And some of that you could predetermine if you're doing a site survey and you're out there scanning for free channels. Well, certainly you can see what's headed in your direction and try to position to avoid it. Verification of radio configuration, we talked about that stuff you could do from the ground, just pointing up at the antenna to determine whether it's on center frequency. And the antenna alignment we talked about. Cross-polarization, that's something also that can be done from the ground. You've got the waveguide and just turn it 90 degrees and determine whether the signal that's coming out of your radio is actually in the right polarization. Cross-polarization, well, that's cross-polarization alignment to make sure it's balanced, that the horizontal and the vertical is balanced. That can be easily seen and done with a Spectrum Compact. Receive signal comparative measurements, and we call them comparative measurements because, you know, at that point you may be on the ground. So it's a comparative measurement. Am I receiving the proper signal strength? Investigation of radio operation, we talked about that. Investigation of radio to an antenna connection, that would be the idea of if you experience a problem and you're concerned about whether it's the radio or something else, removing the radio and mounting the Spectrum Compact on back of the antenna to see what you really have there. Rapid replacement and already installed antennas, and the idea here is that if you're going to swap an antenna, you can mount it nearby, align it, and then quickly swap the radio. That would be an example of an antenna damaged by ice or something like that, where you want a quick transition. and saving spectrum compact curves. That, of course, is for reporting again and further analysis. And that's one of the key features of a spectrum compact, is that you can save all those traces and download them and use them further on. Next, Paul. Well, this here is our territory map, and the Canada and the green section east and Colorado reflects my personal territory, and the yellow reflects Paul's territory, which we call the West and the East territories. Colorado is the exception because I'm in the main office here, and I handle that. Anything else, Paul?
No, that's the presentation. So I guess, Angela, if you would like to open it up for questions, we can field them now, if there are any.
Thank you. Yeah, there was a few questions that came in. I know time is running short, but we'll make this quick. So one of the questions was, how does SAF handle technical support?
Technical support in SAF can come in through an email to technical support. It can come in on the phone, and depending on the time of day, it'll be handled out of Denver, Colorado here, Denver, Aurora, Colorado, from our team here. But if it's in the middle of the night, it could be picked up by one of our counterparts in Riga, Latvia. So we have technical support teams both there and here.
Perfect. Well, that's all the time we have. As you can see, if you have any other questions, Petrus and Paul's email is on the webinar, and we will also be sending a recording of this webinar to all the attendees who attended. So hopefully everybody enjoyed their presentation, and you all have the rest of a good day.
Thank you all for attending.
Bye-bye now.
Bye.